it's normally you have to be under the age of 35, but for Africa, we made the minimum age 40. So you must be under the age of 40 to qualify for the Young Scientist Program, because we take into account that in low middle income countries, there are certain obstacles to people qualifying and getting their higher degrees. So if you're under the age of 40, you will qualify for the Young Scientist Program that will be held in Cape Town next year. And the applications for both the Young Scientist Program and the main conference will open around September this year. And so just keep an eye on the website and look for the opening date. I also put a few pamphlets on the Congress outside yesterday, so there may still be some around showing the details of the Congress next year. And the Young Scientist Program, we provide fellowships to the young scientists to attend both the Young Scientist Program and the main Congress. And so we will cover the airfare and the living expenses, the accommodation, and the registration fee for the Congress. There's no per diem, we cover the expenses directly. And so the one thing is that the Young Scientist Program is very competitive. So when you fill in the application, please make sure that you pay attention to the detail, that you provide the information that is asked for and don't provide information that is not asked for. I'm sure Professor Kappa will expand on that because he sits on our fellowship committee and he deals with all these fellowship applications where people load the application with a lot of unnecessary information, and the people who review the fellowship see through all this and you get pushed to the bottom of the rank. So provide truthful, honest information and stick to information that is requested in the application form. So that's very important. So that relates to the Congress in South Africa. Then the IUBMB also has a large number of fellowships. So we have the Wood Whelan fellowships that allow anybody to travel to another laboratory anywhere in the world. So we cover the accommodation, expenses and the airfare for you to go to for about 3 to 6 months to learn a specific technique. So these are restricted to senior PhD students and junior postdoctoral fellows, also under the age of 40. And you must show, don't just say that I want to go to a laboratory, it's a nice laboratory. You need to have a plan, a proposal of what you want to do. I want to go there, my project does this, and I need to learn this technology in this laboratory, and therefore I need to go, and it will be much more easier and beneficial if I go to the laboratory and learn the technique directly from the people involved who developed it. So you need to motivate very clearly why you need to go. Then we also have the Pro-Africa Bio Fellowships. That is in conjunction with the FASBMB, IUBMB, and the Federation of European Societies for Biochemistry. And those fellowships are more for people to go to Europe. So if you want to go to a specific lab in Europe, you apply for ProBio. If you want to go to a lab outside Europe, to Asia or Australia or USA, you apply for the Wood Whelan Fellowship. And then we also have what we call the mid-career fellowships. These are for people over the age of 40 but who are still in the very early stages of their careers and will benefit in the development of their careers by spending 3 to 6 months in an established overseas laboratory. So those are the mid-career fellowships. Those are for people typically between 40 and 50. And that is to boost, again, your career, to develop, to build contacts, to learn new technologies, etc., that will allow you to do your work and also to establish collaborations with preeminent researchers globally. So the fellowships have specific aims and objectives. So when you apply for the fellowship, make sure you read the guidelines, that you follow the guidelines to increase the chances of success. I think my 10 minutes is probably up, and so I'll wait for people to come with questions and see if there are specific questions, and then I'll hand over to Professor Kappa to deal with the detailed aspects.
Okay.
Before you start, I want us to be practical about what we're talking about. I want biochemistry and molecular biology, biochemists and molecular biologists to lead, to be the leader in this country, especially in the area of this era of AI. Professor Kazim, is Professor Kazim here? Please come. I want you to understand what we are talking about. We should be the best in all our universities. We should be seen as high flyers. And if that's what we're going to achieve in this conference, then we have done. Kazim, come and introduce yourself to us. Is there another one? Okay.
Good morning. I'm Professor Mutiwido Kazim. I'm from Lagos State University, Department of Biochemistry. I'm also the Assistant Director, Research Management and Innovation of the university. For me, I think I was discussing with some groups of young scientists, young biochemists, just before this session. And I said one of those things that will or can catapult you to global reckoning is that collaboration. And there is something you have, but there is also something you don't have. So what you have, you can use it to get what you don't have. And the way to do that is to collaborate. Because what you have, somebody doesn't have. But then what you don't have, they have, or he or she has. So you need to collaborate. So it means when both of you now collaborate, you achieve, they say 2 good heads are better than one. So that is collaboration. So for me, with Professor Kapo, I just discussed with him before now, and that's about, to be up to 10 years now, when I learned about what he does in South Africa. I'm in Nigeria. And I said, okay, I wrote to him that I want us to collaborate in whatever way we can. He's a senior colleague. We are not in the same level. When he became a professor, I think I was still a lecturer 1. And so we were not on the same pedestal. So, and he said, okay, no problem, that we'll be glad that we work together. So, there was a time he invited me. I was in South Africa. Then I did part of my research in his lab, so that I can also come out with, you know, I said publication is one of those key things in building a profile. And for you to build that profile, you need good publications. So not just any. So it means you also need to do good work for it to be accepted globally. And so when I visited, those few days, I was able to do some things, and then I came back to Nigeria, do the other part of it, and we published together. And that also add to my profile, to his profile. And the collaboration still continues till date. So for me, whatever you have, you just need to have something, then you need to collaborate with others globally, within Nigeria and globally, and that will lead us to where we want to get to. You cannot just do it alone and say you want to sit in your own corner. I don't want anybody to steal my idea. We also have that. I don't want anybody to steal my idea, so I don't want to share it with anybody. That idea is already done elsewhere. That your idea is already done elsewhere. So let's share ideas with people that we can collaborate with. Thank you.
Thank you so much, Professor Kazim. Okay, I'm going to take another route. Prof. Kazim, I've just spoken to you about, the essence of collaborations, how much you can achieve when you collaborate, when you work together with people. And we still have our collaboration ongoing. Like he said, we've got a couple of papers and we are still writing together. So that's the way. And I think for the young ones or those in the middle career, middle level career, the way to go about it will be to look for mentors, those who can actually mentor you properly, and those that you can work with, fill in the gaps, research gaps that you don't have, and then somewhere, somehow, you can get to do better. But this session, this morning, is to talk about IUBMB initiatives, pro-bio initiatives, and other initiatives that we as IUBMB and FASBMB has, so that you can take advantage of all the opportunities that are there. I don't want to start spilling beans this morning. I've got so many people I can call here who can testify to what IUBMB has been able to do. I think, but let me call one person, because it will look as if, oh, this guy is in Nigeria, but he's never in Nigeria. He has all his life, he's been in South Africa. So, and he would like to call one other person or two who has benefited from IUBMB or FASBMB initiative. Prof. She knows, you see, I don't even need to mention name. She knows herself. You can come up. So this is just to give you, ideas that what we talked about, when we talked about IUBMB, FASBMB initiative, you've got people who has actually benefited from these initiatives, and they can tell you their experiences about it.
Thank you very much, Prof. Fellow biochemist, I am a beneficiary of IUBMB and how they can give platform for a biochemist to grow. Way back during the COVID-19, I won't say it's out of boredom, but I attended a program just before COVID organized by FABS, meant for postdocs and PhD students. And that was when I came across the opportunities available in IUBMB. So during COVID, I explored it, and I was given the opportunity to go to Israel as a fellow, as a mid-career fellow. I spent 2 months in Israel, and I'll say that's laid the foundation to what I currently have in my laboratory. I'll say my lab has one of the most established line for tissue culture, for Western blot, and every other thing that is available as a biochemist. So, and together with Professor Capo, we are now looking at an opportunity where our lab can serve as a center for pro bio Africa, whereby as against biochemists competing to go outside Nigeria to do some of these things, applying for 7,000, 8,000 euro, they have the opportunity to apply for half of that, and that will give them the opportunity to come into our lab. As mentioned earlier, we have bioimaging facility, one of the latest confocal microscope. We have a molecular imager, a well-established tissue culture facility, and we are looking at that together with FAS and IUBMB so that individuals can explore it. I don't know when is the next call for ProBio. So next year. So we can always talk about that ahead of time.
Thank you so much, Prof. Yeah. So I'm just trying to make people feel excited about the opportunities that are there before, I'll not build on what Professor Parker has just spoken about. The fact is that we've got people within our midst here who has actually used those opportunities provided by IUBMB, FASBMB, to actually kickstart their careers or move their careers, to a particular level. Do I have time? Can I call 1 or 2 more persons within? Okay, I would like to call on the international biochemist. She knows who I'm talking about. So let's put our hands together for Dr. Tade Jawanisi. She calls herself international biochemist. So she will tell you why she calls herself that. And she will tell you what she has also, enjoyed, with her affiliation with IUBMB and FASBMB.
Thank you for this great opportunity. I'm called an international biochemist by inspiration, because when I looked at myself, I did my first degree, second degree, and all other degrees in Nigeria. Then I called on Professor Bilbis then that, see, I don't want to be a local biochemist. I want to be an international biochemist. And so how can I belong to the international community? He said, the moment you are in this, our society, you belong there. I said, no. He said, individuals don't go there. But deep inside me, I said, I'm going to go there as an individual. So within 5 years of your PhD, you can go for an advanced school. I now saw an opportunity for an advanced school in 2018. And then NSBMB was not very active in IUBMB, or payments were not made. So I wrote directly to the local organizing committee there. I wrote a heartfelt letter. I like poems. I wrote it in a poetic way. And when they read my letter, they got back to me and they said, whether your society is active or not, we're going to give you this grant. They gave me a grant. So I went to Serbia for the advanced school. And that was one benefit. And with that collaboration, for going to Serbia, I know a lot of IUBMB officials, even past officials. And I want to tell you again, just a week ago or 2 weeks ago, I got grant for somebody to go to Poland. Just because I bulldozed my way there as an international biochemist. She met me in Setco after I gave my testimony, and she tapped me that I want to be an international biochemist. I said, okay, just hug me. and get the anointing. So when she heard about Enable conference coming up in Poland in October, she pinched me, and the deadline was coming. The age limit was a problem. It was 35 years. I said, don't worry, you are going. We started letters overnight. And I wrote to the chair of the fellowship, and I got to my friends in IUBMB. I said, are you still there? That for Africans, we age before we go to school. Can you please drop this age limit for us? And I got an email that we're going to change it, and it was dropped. As I stand here, she has already received the grant, and she'll be going to Poland. What I'm telling you is that don't underrate yourself. You can get there. There's no stopping us, and we're going. Thank you very much.
Thank you so much. Thank you so much. Thank you, thank you. So these are just some of the testimonies from those who has been funded or those who have enjoyed. Okay, so for those who have actually enjoyed all the largesse from IUBMB and FASBMB, but let me just quickly round up. I would have loved to call one other person, but I think the chair is telling me we have 5 minutes. But I think I should. I'm the program director, right? I'm directing this session, and I can use my veto. Okay. Let me call one more person to just come and tell us how well you can apply for IUBMB and still get, Prof. So you see, I may not be in Nigeria, but I know everybody who are Nigerians who have been funded by IUBMB or FASBMB, because the application comes through our committee. And I sit on those committee and I read very beautiful proposals written by a lot of people from here. Prof proposal is one of the best proposals we've read in a very long time. And she's just going to tell you about it now.
Thank you very much. First and foremost, I'd enjoyed ICGB combined IUBMB travel grants in the past. When we came for FASBMB, I was feeling I'm overaged to be funded by grants. But when the education fellowship came up, IUBMB, I just took a dash and got a placement with Middlesex, UK, and applied. And 4th of March, I got the award letter for the 3 months FEBS fellowship, and I'll be starting in September. Thank you.
So by September, Prof will not be in Nigeria.
I guess you have to say, how many months? How many months? 3 months. And she'll be away, fully sponsored by IUBMB. Can you put our hands together?
Okay, so let me open the floor for questions. Maybe 1 or 2 questions before we close this session. By show of hands, okay, I see one person there. Is there any roving microphone anywhere? Any other hand? I can only see 1. Oh, okay, 2. All right. And then, okay, let me start from the person at the back. Did you have your hands up? Oh, okay. So let me start with you, my brother in front here. Hello? Yeah. Please make it quick because of our time.
Thank you, sirs. Mine is a comment, and my plenary will actually cover some parts of the IUMB experience. But specifically, I want to talk about the experience we had with one of my students. I was also opportune to be a YSP fellow in Seoul 2018. I also won the IUMB fellowship travel grant. And so sometimes around 2022, I now said my students should apply for the Wood Wayland fellowship. And the first attempt, and that is the message I want to give my fellow early career biochemist. The first attempt, he did not get it. Then I told him that let's study the the rejection letter. We studied the rejection letter, and then I said by next year we are going to address everything, and when you apply, I'm sure you are going to get it. And so we spent a year to, what we did essentially was to ensure that we publish an article with the other party. And as soon as he applies next year, he got it, and that is actually what catalyzed and allowed him to complete his PhD. Also, another of my mentee also was able to also get the ProBio Africa, and he traveled to Singapore. Also the same pattern. First attempt, he did not get it. I told him, let's strategize again, you will get the second one. And he actually got the second one. So that is the message I want to pass. Even if you failed the first one, just go for the second one. Address the problem, and you get the second one. Thank you.
Thank you so much. Okay, so let me just round up this session so that we can get on with the other things. Okay, one, there are so many fellowships that are available for you to apply to. Prof. Parker has just mentioned the various fellowships, and if you go to the IUBMB site or the FASTBMB site, you will see those fellowships there. And like he has said, all we are looking for is just a 2 pages or a 2-page proposal. It's not a very big proposal. We're looking for a 2-page proposal. We're not looking for a very big document too, because we don't have that time. We get a lot of applications from all over the world. So if your application, you don't follow, the rules, then before you know it, it gets thrown out by the IUBMB secretariat. It doesn't even get to us, where we'll have to sit and read and then make a decision on it. So a 2-page proposal is all what is needed. And then, like he said, we also want you somehow, because we know you are a junior fellow, to have at least your name on one publication. It doesn't matter whether you are first author or 50th author, but we would like to see that you've contributed something, to the advancement of knowledge. So, and the only way you can show is not because I don't know you, you don't know me. The only thing I know is looking at your CV and then seeing, if you've got anything published. So once you've done that, the other ones is, are you a member of your local society, which is NSBMB? Yes, you are. And then you put in your certificate. You get a letter of support from your university. You get that letter of support, and that is all. You attach it, and then you give us a budget. Now, let me sound a note of warning. Oftentimes, we get, outrageous budget from people. I can tell you, the FOBA Africa this year, we were only giving 5,000 euros. And we got somebody giving us a budget of $27,500. So when we looked at it, the first thing, we didn't even look at the application, we threw it away. Straight away, we threw it away. Then we also have people budgeting for, if you go to any university overseas, your internet cost is covered. You don't need, you enter the university, your phone automatically should pick up the internet. You are not even going to be prompt. Your laptop, you should be able to sit anywhere, and then you get your laptop connected to internet. And we get people saying that no, they need internet cost of $1,000 per month. So you see, all those things doesn't show it doesn't show honesty. So the other thing we look at is honesty. We want to find people who are very honest when you apply. Show some level of honesty so that we can trust you, that when we give you the money, you will use the money for what it is meant for. We've got some bad experience in the past. I'm not going to lie to you. And nowadays, if Prof. EJ will tell you, she's only going to get the money when she gets over to where she's going. And the reason why that happened was because we funded Nigerians in the past, and we paid them before coming, and they took the money and they never showed up. So this is us, within ourselves. I think we've got to tell ourselves the truth, because those who did that in the past, they've actually blocked the way for others. Now, even when we give you the funding, we expect you to find the money to take yourself to where you're going to do the research, and then when you get there, that is when we then give you the money. It shouldn't be that, because that is not the way we set up the fellowships to be. But because people have taken the money, they don't show up. I was sitting on the committee where we wanted to have symposium, and we paid 4 Nigerians. We paid 4 Nigerians, and they never showed up. They took the money and they never showed up. And my other person was like, no, I'm sure maybe it's flight. They will show up tomorrow. Tomorrow, the next day till we finish the whole training. They didn't show up. That is not speaking good, about us as a nation. I sit on those committees and I get to hear many things that people say. And people from Europe and the US, they tell you off straight away. They don't do this eye service. If it's wrong, it's wrong. They tell you this is nonsense, and that's it. So please, that's why Prof. Parker was saying, be truthful, be honest when you do the application. Don't budget for what you don't need to budget for. If the budget is 7,000 you can get, my advice to people oftentimes is that budget less than that. In fact, if it's 7,000, give a budget of 6,950. So that eventually, this one does not even want all the money. And then that actually increases your chances, of getting the fellowship. Don't budget $10,000 or 10,000 euros. So those are just the little things. The next ProBio Africa will be open next year. The one for this year, we have done it again. But to say something good about Nigeria, we always have Nigerian students applying and they get it. This year we have 4 of them being awarded this year. So that is good. From Woodwillan also, we have Nigerians also applying, and the applications are good. I mean, I would want to commend those guys from Nsukka. Is anybody from Nsukka here? We've had so many people from Nsukka who have been getting this application. Maybe they teach one another in Nsukka how to do the applications. I don't know. But they've been very, very successful over the years. Even this year, we have 2 people from Nsukka again who got it. So we would like to open it to everybody. You can apply. That's done. That's ProBio Africa. Woodwillan, if you are over 40, you can apply for that, and you are not a professor yet, so you can also apply for that. The other one I want to talk about to round up is the YSP for IUBMB 2027. Okay, let me say something here. I'm not South African ambassador, but I'm going to tell you that a lot of these things you see and hear about South Africa are actually not what it is on ground. I will tell you that. I've lived in South Africa in the last 27 years, uninterrupted, and I don't think anything has happened to me, my family, my kids. They go to schools. In fact, my kids represent the province in sports. I mean, my son captains the rugby team, of the province. That is the state. My son captains the rugby team, and nothing. Nobody has said, because you are born of a Nigerian, man or parent, you can't do this. But what I'm saying is that there have been a lot of, negative information. We know the beef between Nigeria and South Africa regarding which of the 2 countries has the big economy, or which one has the bigger country in Africa. We know the beef is there. So for next year, I've got people asking me, are we safe when we come to Cape Town next year? I want to promise you, you will find me there and you will be safe. The other people who have asked me, are we going to get visas? I can tell you confidently, you will get visa. And as I'm talking to you now, I have a student from Bangkok University in my lab. In my lab. In fact, she came 2 days after the whole problem started, and nobody stopped her at the airport. She's there in my lab. So I'm using this, this occasion again to welcome you to Cape Town. For those who will be coming, please apply for your visa. It's even online. So apply for the visa, get the invitation letter, get your abstract submitted, register, and you will get your visa. I can tell you that. You will surely get your visa. So forget all the deep fakes and the AI and all those things. Even when I was coming, I was even asked. And let me just tell you a joke that Prof. Parker just told me. When he applied to the university, is coming. So university said, okay, when we travel, we have this travel insurance and medical insurance, which we get from our university. It's automatic. So you just fill your names and then boom, you print it out and then you get it. But it also depends on where you are going. Now, on his travel insurance, it was written there, the first line in bold on top, that the university does not pay for ransom. So you better make sure he's safe here, and I'll make sure he goes home in one piece. So that the university does not pay for ransom. And the same thing for me. Even the dean of my university said, no, you can't go there. That place is, I said, but it's home for me. Why will I be scared of going home? So you see, so please, a lot of the things that we are hearing, yes, we know there are challenges with security, but we have been here since Sunday and we've had wonderful time. So I will just say that please apply for the YMB program. NSBMB is also going to sponsor African students to that same Congress. We have a budget to sponsor 10 African students. Other than the YSP that IUBMB is sponsoring, we as NSBMB, we also sponsoring 10 extra. So please apply for that. Thank you very much.
Thank you so much. No, sir, sorry. We, on behalf of NSBMB, I want to thank you for opening our minds and our eyes to have an understanding of what is happening outside of here. Professor Parker, we are also very grateful. There may not be, because of time, there may not be room for questions and answers. Rather what will happen is that they are not leaving now. They are going to stay with us, so feel very free to interact with them. Ask any question, you have answers. Thank you so much.
A round of applause for our speakers. We can do better, please. So we shall be going to our plenary session now. Before then, I just want to tell you that if you want to listen to some of the things our speaker has spoken about, we will send the YouTube link to you. You'll be able to listen to it clearly and audibly. Having said that, some of our most of our researchers that have products to display, or that want to just tell us what he has produced. After the plenary session, we shall be calling on you 2 minutes to come and tell us what you've produced and what it is for. So we shall be going to the plenary session. Before then, I will try to call on the chairman of this plenary session. We'll be running 2 plenary sessions concurrently. It's my pleasure to call on this professor who will be the chairman. He's a person I have known for close to some years. He understands excellence. To him, excellence is borderless, creedless, and raceless. And meanwhile also, is also the editor-in-chief of our journal. It's my pleasure to invite Professor Ahe Umar from ABU to be the chairman of this plenary session. A round of applause for him. He has done so much for the society and we're going to do more. Having said that, I will be calling on our rapporteur for today. He is also a lecturer that I have known for a while. Vibrant, young in heart and in mind. Research focus and research. I will be calling on Dr. A.D.A. Omoboyowa from Akunga. So, please come on the board. Having said that, let me use the pleasure to invite the first plenary speaker for today, in person of Professor Mohammed Awal Ibrahim. He will be speaking on establishing a biochemistry and molecular biology group for health impact in this AI era. So a round of applause for our speaker. Having said that, I will call on Dr. Mrs. M.F. Adisa to come and do the citation of our speaker, Professor Ibrahim. You can come. You can come forward.
Brief profile of Mohammed Awal Ibrahim. Mohammed Awal Ibrahim is a professor of biochemistry and molecular biology at Ahmadu Bello University, Zaria, Nigeria. He is also the Deputy Director at the Directorate of Research and Innovation at ABU. He obtained the BSc Biochemistry from ABU as the best student of the department for the year and an MSc Biochemistry from the same institution. He proceeded to the University of KwaZulu-Natal, South Africa, where he obtained a PhD Biochemistry, which was followed by a 2-year postdoctoral fellowship at the Biotherapeutic Research Group, University of Pretoria, South Africa. He was also awarded a research fellowship by the Japan Society of the Promotion of Science, tenable at the National Institute of Advanced Industrial Science and Technology, Japan, between 2019 to 2021. His research is mainly focused on molecular biology, biotherapeutics, drug design, and discovery targeting trypanosomiasis, malaria, and type 2 diabetes, where he applied a number of techniques such as recombinant DNA technology, in vitro analysis, and preclinical trials. Professor Ibrahim has authored more than 120 scientific articles published in internationally recognized impact journals. His publications have produced more than 4,000 citations with an H index of 35 and I-10 index of 82. He has also authored 4 book chapters published by international publishers and has supervised and successfully graduated 38 MSc and 3 PhD candidates, including candidates from South Africa. Presently, he is supervising more than 25 MSc and PhD students across the nation and South Africa. He has attended a number of workshops and conferences across the United States of America, Kenya, the Gambia, Madagascar, where he also presented more than 40 papers. He also served as an invited keynote speaker for conferences and seminars in Turkey, Bangladesh, and Nigeria, including plenary speaker at 2024 conference of NSBMB and also Biotechnology Society of Nigeria. He also served as external examiner to universities across the nation and South Africa and India. In 2023, 2024, and 2025, he was both ranked among topmost 2% most cited scientists in the world, as analyzed by Elsevier and Stanford University, USA. Professor Ibrahim has won many awards and travel grants, including a grant to attend the first West African workshop on the cell biology of protozoan parasites by the American Society for Cell Biology, and an international grant by the Kate R. Porter Endowment for Cell Biology at Philadelphia, USA. This is in addition to travel grants from United States National Academy of Science, Engineering, Medicine, World Conference on Research Integrity, among others. He was also a recipient of 3 competitive research grants from the University of KwaZulu-Natal, South Africa, and a co-investigator to a research grant from the National Research Foundation of South Africa. In Nigeria, he received an institution-based research grant from TED Fund and the National Research Fund as the principal investigator and co-investigator to 5 other TED Fund and NRF grants. In 2018, he became a recipient of the Young Society Program Fellowship by the International Union of Biochemistry and Molecular Biology and attended the 2018 Congress at the IUBMB in South Korea. Most recently, he is a co-investigator to the 2025 Horizon Europe Global Health Grant to West African Network of Excellence for TB, AIDS, and malaria, worth over 20 million euros. Within the same year, he also received 2 grants as co-investigator from the World Association for the Advancement of Veterinary Parasitology. Professor Ibrahim is a fellow of the Japan Society for the Promotion of Science, a fellow of the African Science Literacy Network, a fellow of the Nigerian York Academy, and an affiliate member of the African Academy of Sciences. He was also the president of the Young Academy from 2021 to 2023, and presently a member of 4 other scientific associations, including South African Council for Natural Scientific Professions, NSBMB, and also BSN. He is the Deputy Editor-in-Chief, Production of the Nigerian Journal of Biochemistry and Molecular Biology, and a member of the Constitutional Review Committee of the Association. He holds online certificates in teaching and learning courses from the University of Melbourne, Australia, and the University of Hong Kong. He is greatly involved in science communication and public engagement for scientific awareness using radio programs and online magazines publications. Lastly, Professor Ibrahim is a regular reviewer to dozens of high-impact scientific journals and is married with 4 children. Please make welcome Professor Ibrahim Mohammed Awa.
Thank you.
I'd like to hand over to the chairman so that you introduce me. Thank you very much, Mrs. Adisa, for reading the citation. I'd like to hand over this session to the chairman of the session, Professor Haye Umar. Thank you.
Thank you so very much. A very good morning to all delegates that are here. But I think you've not shown enough appreciation for the, yes indeed. Thank you. For a young man to have achieved so much, I think we needed to show him that he has done well. We are going to take 2 plenary speakers this morning. The first one is one before you now, Professor M.A. Ibrahim. He will be the first plenary speaker. The second plenary speaker is still being expected, as I'm told. This is how we shall proceed this morning. We shall take the 2 plenary lectures, one following the other, and then take questions at the end of the second plenary lecture, because we've already lost time in our program. So without further ado, I will call upon Professor M.A. Ibrahim from the Ahmed Bello University, Zaria, to present his lecture. I hope you will all enjoy it. In fact, I'm sure you will all enjoy it. Thank you very much. Mr. Speaker, you are allotted 20 minutes for your presentation.
Okay.
Yes, I'm told.
Okay. Thank you so much, sir. The chairman, who happens to be my mentor, it's really my honor and privilege that Professor Omar is chairing this session. It's indeed very touching to me. The executive council members of both IUBMB and FAST BMB, the executive council members of the NSBMB, LOC members, fellow plenary speakers. Of course, I have to especially recognize the fellows of the Nigerian Young Academy, other distinguished guests. A very good morning to us. First, let me appreciate my sincere gratitude to the LOC and, of course, the ESCO for inviting me to present this talk, despite the fact that I presented similar lecture just last 2 years. In fact, I was so surprised when I received a call from my very good friend that they have pinned me down to present this. Then I said, what am I to present again? And then I consulted my mentor, and then my mentor told me that go and present progress report from 2024 to 2026. And essentially part of what I'm going to do will also have to do with just progress report from my last presentation to this presentation. Also, the title is, as presented, establishing a biochemistry and molecular biology research group for health impact in the AI era, the MY lab model. MY stands for Mohammed Awal Ibrahim, but I'm going to also redefine it as we proceed. Now, in addition to the fact that I'm going to give a progress report per se, there is a very, after my last plenary lecture in Port Harcourt, I received not one, not two, not three, not dozens. I received more than hundreds of communications from fellow early career biochemists and molecular biologists. More than 100, much more than 100, they have communicated with me. And I kept saying, everything revolves around that how are they going to also navigate similar paths like what I've presented there. Therefore, essentially my presentation today, I'll also, in addition to giving the progress report, I'm also going to largely focus on a demonstration on how you can actually, as Nigerians, biochemists and molecular biology, how from right now you can actually start to build your lab. Like I said, this is essentially for the early career biochemists and molecular biology, my fellow colleagues, and I hope they have not disowned me yet. I'm glad when Professor Omar also referred, I'm still part of the clique. Please don't disown me. I still belong to that clique. Now, so to answer the question for my fellow early career biochemists, I want to start by showing this, what I call the vicious cycle of academic excellence for early career biochemists. Now, this is a demonstration. This is a very vicious cycle that you should try to always be focused on. You start in both directions. Others start from journal publications, then push to grant. Grants will lead you to mentor postgraduate students and back. Or in both directions, that is how this actually operates. And I will also focus and also give us story. My story will largely be built on this experience, how you can use this vicious cycle as a template to actually catalyze your progression from where you are now as early career scientists, either completing your PhD study or even have finished PhD study or completing, and then you are still trying to advance. Now, I want to start with the progress report. This is to essentially motivate. Then to motivate us that this thing is possible, then from there we now also use that to demonstrate the earlier vicious cycle. Now, within the year, I think specifically last year, I was opportune to be in a research consortium that actually received a Horizon Europe grant worth over 12 million euro. That's around $19 million. And essentially, as you can see, essentially our focus is actually to train about 12 young scientists in the areas of TB, malaria, and neglected tropical diseases. Okay, that's it, sorry. Now, essentially that is what we are to do as a group. That's what we are supposed to do to train them. Also, within last year also, we also happened to also got a grant for BioAtlas, essentially just like what was discussed yesterday about personalized medicine and also genomics. Our essential duty here is actually to collate baseline genomic analysis of patients, and for my part specifically, I will be focusing on cardiometabolic diseases and type 2 diabetes. We are going to provide baseline genomic data for patients, African patients, or rather Nigerian patients that have this. So far, I have 2 students that are currently working on it. I think the grant for everything is about $200. Now, for the local NRF, we are also opportune within the year to be co-investigators to 4 different NRF projects. I'm glad some of the reviewers that interrogated me, some of them were here. And this is approximately about 100 million naira. And also, I also became a co-investigator to this project for both of them combined about 150,000 US dollars. So, I've demonstrated this, like I said, this is a progress report from 2014 to 2026 to demonstrate to us as early career scientists that this is actually possible. And now, how do you actually establish a research group so that you attract these grants? This is the vicious cycle. You have grants, you establish group, or you come in the reverse direction. Both ways can operate the way the way it fits you. Now, I showed this in my last presentation in Port Harcourt. Now, this is generally my area of research, largely revolving around trypanosomiasis, malaria, and type 2 diabetes with a number of intersections. Now, for the day, I'm going to demonstrate how, by God's grace, we are able to develop a research group in 2 different areas. How you can actually, and you just have to start now as early career scientists. I'm going to focus on drug discovery around trypanosomiasis. I'm also going to speak a bit about biotherapeutics, specifically peptidomics. I'm also going to talk about novel therapeutic targets against diabetes, especially from the perspective of the role of cyanobiology. I'm going to discuss, give us how all these things actually came to be. Now, the first model that I will really want us to, as early career scientists, to start looking at. Now, this first model is about anti-trypanosome drug discovery. Now, somewhere in 2011, I think specifically during the fuel subsidy crisis, is it crisis? Sorry, it's not a crisis. Fuel subsidy strikes. I think I just conceived an idea, but then while we worked with mentorship of Professor Omar, we have worked so much on anti-trypanosomal medicinal plants. Then I said, see, we have been revolving around the same cycle. I think I should provide a review that will give the entire African continent a direction. Then I started that project from 2011, or rather 2012, January, thereabout, and eventually we published this article in 2024, where we demonstrated that for 20 years we have been doing the same thing as Africans, and if we are to proceed, only so far out of 264 plants that were investigated then, only 48 compounds were actually identified, and then among them only one was validated in vivo. So it's kind of weird. We are not making progress, moving around cycle. So the conclusion of that article was that we should conduct, for us to take some of these compounds along the drug discovery pipeline, it means therefore some of these compounds, and that is one thing you should always be focused, things that are coming on board quickly fit in, as I'm going to show us also more of that. So as of then, I was able to integrate in vivo trials in vitro study and also molecular docking. By that we are able to successfully then demonstrate that our candidate ellagic acid was able to actually retard the proliferation of Trypanosoma congolensis. It also, but interestingly, it was able to serve as a competitive inhibitor to a very important enzyme, Trypanosoma sialidase, and we also tried to model using molecular docking to see what happened. Then the same person, next compound, you also checked sigmasterol. Then after that, another, so you see from that paper we already have 2 articles by one student and 2 solid articles. Then another student came, Saad, he came, and also I said, also pick 2 compounds from those 48. We rationally decided on those compounds. He picked the first one, phytol, and we also conducted fairly similar study, and we had the result as presented. We demonstrated that actually phytol had therapeutic potential towards Trypanosoma congolensis infection, and also it actually inhibits Trypanosomal sialidase. Now, the same student, like I said, he needed to work on 2. He also investigated geranyl acetone, where we also demonstrated that it is also fairly good, and it also uncompetitively inhibit Trypanosomal sialidase. Now after that, after 2 MSc, I now post that there is need to advance. We should not be doing the same thing, and that is what I'm calling all our attention to. You should advance. Now I said, how do you advance? 2 perspectives. We have, as of then, around 2018 or so, we should expand from molecular biology perspective, and we should also expand from the computational perspective. The molecular biology perspective I'm going to show us, and specifically for the computational work, we try to expand from the perspective of using molecular dynamic simulation. So another student who is a colleague in the department, Suleiman Wali, joined the research group. We said that let's also pick another compound from that same group, from the 48 candidates, this beta ion, and let's see what happens. We have earlier been working with proteins, with Trypanosoma sialidase protein. Now I want to see what happens at gene level. How are some of these compounds, in addition to their anti-Trypanosomal activity in vivo, how are they able to also influence the gene expression pattern of different variants of Trypanosoma congolensis transialidase? And that is what we subjected to. We had about 4 different variants of Trypanosoma congolensis transialidase, and we now said, okay, let's see, let's move from protein, let's move to what happens at the genetic level. And he has conducted the study in very interestingly, very unique finding. We are able to find out actually among the different variants of Trypanosoma congolensis sialidase, our compound was only able to act on T1TS3, which is another variant, and T1TS4. But T1TS1 and T1TS2 were largely not affected by the compound. This is a very good piece of information for us to tell us so many things as whenever we want to move further. Then the same student, a colleague also, like I said, he also picked 2. He also picked beta cytosterol. We also demonstrated that in the case of beta cytosterol, it is actually able to inhibit the gene expression of T1TS1, while beta ion was very potent in inhibiting the expression of T1TS3 and T1TS4. This is a good piece of information as we gather the data over the years. Then another student came. We also went further to also check for eugenol, which is also one of the candidates. Now we are dealing with 5. Also, this one actually worked on almost all the variants, T1TS1, 2, 3, and 4. So after that, like I said, we are advancing. Our ultimate goal is to see that for those 48 compounds that we started with, how do we eventually end up with a product? That is actually the ultimate goal. But along the way, we kept a bit, or we kept diverting a bit. So another form of advancement that we brought forward was in the case of beta cytosterol. Because of its unique feature, we now said that in addition to its action on the details, there's no time to give details why we needed to deviate at this level. In addition to its activity against Trypanosoma congolensis sialides, there is need to also see what happens to Trypanosoma phospholipase A2. So we also did in vitro study and we subjected it to enzyme kinetic study, and very importantly, we now introduce another parameter that will further advance our study, and that is molecular dynamic simulation. That was 2019 thereabout. Then we now advance. So we now advance from that point, and that demonstrated to us that actually beta cytosterol is actually a dual inhibitor of the compound. We are doing this actually to guide us overall. After some years, the target is to see that we have something on ground as something that is developed from the African continent. Another student, Abdurrashid, also came. We also checked fluorogluconol, and he also had a very fantastic result. I'm going to summarize this very importantly. The summary of this is two things I wanted to demonstrate here. One, as young scientists, you need to start making your decision now. From your PhD thesis, from some basic research you do, try to start building from that. You can see from one paper, we are able to generate about more than dozens of papers. Some are not shown actually. Dozens of papers and serious papers, as we can see. And also we are able to keep advancing. We keep advancing, and that is the message I want to ultimately also pass to my fellow early career biochemists. The studies have gone very fast. So that is why we are, and that is the ultimate the studies have gone very fast. So that is why we are, and that is the ultimate message I want to give us. Now, after this, the next thing we ask ourselves is, don't forget we started, then we now say let's advance using molecular biology, gene expression, and also molecular dynamic simulation. The next thing we said, okay, there is also a need to further advance. After 2-3 years, we should not wait, we should advance. Now, that is what take me to second model I want to demonstrate to us. We now wanted to advance using techniques that are actually applied by the even big pharmaceutical companies. That is what we want to now pursue, and this revolves around recombinant DNA technology and also fragment-based drug discovery and also AI. We now put all this together. Now, very important, just like the way I had one of my friends telling my fellow early career biochemists that good papers usually attract more opportunities for you, and that's exactly what happens here. It is the build up of those papers that we mentored through using the student that eventually also took us to recombinant DNA technology, took us to fragment-based drug discovery. Now, for fragment-based drug discovery, we target a very important protein called the Trypanosoma brucei phospholipase C. It's a very important enzyme, especially with respect to antigenic variation in trypanosome. It is a membrane protein, very difficult to work with. I have shown this in Port Harcourt, but I gave the entire story. The basis for showing it here is just to remind ourselves and to see how I stopped here in Port Harcourt, and I want to demonstrate how we actually built up from this data. As a recap, here what we did essentially was to clone and express Trypanosoma brucei phospholipase C, and this we can demonstrate the success of the induction. Eventually we made several attempts to crystallize the protein, though not very successfully. I was happy with the plenary lecture yesterday. I think he made a number of presentations along that line. Then we subjected the recombinant protein to first biochemical assay, and then to a very important technique called the water-loxy NMR technique. Eventually from that we actually screen specifically 864 different fragments, but we are only able to identify 10, which are our key players now that we are actually playing with. The key message is how, like I said, I presented this up to this point in 2024. Where do we move from here? Now, we are aware of the fact that this protein is a membrane protein. We look at it from therapeutic potential, but there is need, because of its unique character, it also have some vaccine potential. And along that line, we also have a student that is currently investigating the AI-assisted design of an epitope-based DNA vaccine against the protein. So you can see, moving from basic natural chemistry, today this is landing us into recombinant DNA technology, and that is now leading us into AI. Now, some of the findings so far is that we are able to actually identify B-cell, cytotoxic T-cell, and also helper T-cell epitopes from the trypanosomal proteins, and among them, I think the number is there for B-cell epitope. For instance, we have 34 different proteins that have that epitopes. Then we did what we call a protein embedding using ESM2. ESM2 is actually a large language model that actually guides us to use our protein and query use our unique protein and query the other epitopes that we have actually obtained. Now, after that, eventually we are able to realize that the protein has about 300 different epitopes, and our target essentially is to construct a very unique DNA vaccine that has all these features, because these are what are needed that should be embedded in a DNA vaccine construct. Now we have beta cell epitopes, we have 303, and for cytotoxic T cell epitopes, we have 271 and 297 for helper T cells. Then, after getting all these fragments from our protein, using, of course, this was written, we actually instructed AI to write a Python code for us to make this identification. So this is now, we are now moving into AI. Now from there, after getting those, using the Python, we actually are able to identify 75 fragments and 58 fragments for MHC1, which goes to with cytotoxic T cell, and also 86 fragments. Then these are our candidates. We want to have at least one optimum combination that once we are able to construct the DNA vaccine system, actually it is likely to work very much. Now, we know these are some things actually affect the potential of vaccines. So all the epitopes are subjected to antigenicity using Vaccine 2.0, B anti-cell binding, allergenicity, and toxicity. This is to make sure that when we are able to construct our DNA vaccine, it is going, we have, by then we have nullified all other problems that are known to be associated with DNA vaccine. Now, I think eventually at the end, we ended up with 11 fragments that are non-toxic, and also have passed all the screening steps as shown, from antigenicity to B anti-cell binding to allergenicity and also to toxicity. Now, this is the final selection, and presently we are actually attempting to construct and optimize an epitope-based vaccine from that data, and which has now been identified using different AI tools. Now, that is why we are, in fact, I think the construction has been done. We actually randomized, and we had about 400 and something different combinations, and from there we are now narrowing down to 10, and eventually we will construct about 5 of those 10 so that we test them, and then after identifying the candidate, we can successfully amplify the candidate, clone it onto PET15B system, and also successfully get the sequencing, and also successfully amplify the protein. Express the protein, and we express the protein, and also successfully purify the protein. After the purification, in that case, we directly subjected it to water-loxy NMR. also with our 885 different fragments. And from there, as I'm going to show us, we had only one candidate which we now subjected to further studies. Now, this is what we are able to show. We are able to successfully amplify the gene. We also successfully conducted colony period. Another study, we now made a switch a bit, and we use zinc database now, compound commercial database for commercial compounds. We are able to also identify unique compounds that actually target trypanosomal, congolensis, lysosomal alpha mannose. Now, with about, as of then, with about nearly 1 decade of computational study, I said we should take a pause. We should review what are the limitations of computational drug discovery. We actually started looking at the limitations. We have identified one limitation, which I'm not going to dwell into, but I'm glad to report that from that limitation, we are able to actually conduct study. We are able to develop a new pipeline, never seen, and we have successfully filed a patent for it. All over. Now the patent has been filed in South Africa, and we are waiting. Like I said, I wouldn't want to say much. It's actually titled "A Computer Implemented System and Method for Dynamic Consensus-Based Evaluation of Molecular Docking Outcomes." The patent has been filed last month or last 2 months. So overall, we can see that this is a summary. You can see that starting from foundation with the review article, around 2014, we moved to validation of natural product around 2017. From 2019 to 2020, we expanded the mechanistic insight using gene expression and also dynamic simulation. We also advanced in silico, and we also started integrating biotechnology, recombinant DNA technology, biophysical system, structural biology, and others. Cryo-EM, even though I have not shown that. Cryo-EM technique, we all integrated them into our system, and eventually we are ending up with an intellectual property. We are ending up with a patent. And of course, we hope this is not the only patent. We hope more patents, especially from the product, is actually, we hope that is going to be produced. So this is driven by purpose, guided by science, and also committed to making impact. Now, very quickly, sir, I'll also just in the next 2-3 minutes, I'm also going to talk about the third model, and this is the last model. It's a short one. Now, this one come into being also. I'm also want to use this to also talk to fellow early career scientists that I started having this idea while conducting a PhD, while as a PhD student. I started reading literature, just roughly. Honestly, this was, I would say, by serendipity. I just noticed that as I write my thesis, I used to see medical papers were writing the fact that, or demonstrating that sialic acid is always elevated in type 2, in different kinds of type 2 diabetes. This is by chance. One day I was sitting, I said, okay, as if I saw this report in Pakistan, I think I saw it somewhere in England and Sweden and somewhere. I started thinking, then as biochemists, this is what the medical doctors are reporting. Part of just reporting that there is high in patients from Pakistan, from England, from Sweden, and so on and so forth. I said that I think as a biochemist, my role is to find out what is responsible for that. And that's actually how this story starts now. I said I want to find out how that starts. Now, this is just the summary as of then. So many studies, I just picked it up. Then I now got students. I said that let me see what happens. Let me find out the scientific basis for the increased sialic acid output in type 2 diabetes, which has been reported by so many medical papers. Then, of course, we have advantage over the medical system where they can now work with organs, but our advantage is we can model the disease and also work with tissues. So I now subjected have diabetic papers, diabetic groups and all different 2 types of diabetic groups, and essentially see what happens to salicylic acid output in the different organs. And it was interesting to find out that actually liver and kidney were actually having higher salicylic acid output, and also the pancreas was actually down-regulating the salicylic acid level. That is the first information we have gotten. Then 2 students came. I said, okay, we now know that actually there is actually a change in the salicylic acid metabolism among different tissues and organs of type 2 diabetic animals. The question is, what is responsible for that? We now hypothesize that perhaps it's the recycling system. What we mean by recycling system is the sialidase and also the the sialyl transferases that may be key players. And so I subjected 2 MSc students to this project, and eventually we were able to demonstrate that indeed sialidases and sialyl transferases are actually enabling the...
But as I earlier explained, we shall take the second plenary lecture. Then if you have questions, then we'll now discuss them at the end of the second plenary lecture. So if Professor Ibrahim could please sit, so that we can now get the second plenary lecturer. I understand he is around somewhere. Where is he? No, I know it's close. But they're supposed to read his citation. Who is going to read his citation? That's why I want to see the... Okay. We now call Professor Godwin Ojo Igele to please step forward in preparation for the delivery of his lecture. Where is he? Okay, please a hand of applause. Yes. Okay. All right. You're welcome, sir. You're welcome. Thank you very much. Please take a seat with him, then we'll find somebody to read the citation. LOC? Okay. Citation, the person to read the citation, please. But they had the best one. Yeah. They should have prepared for it. Or maybe they weren't sure he would come. Yes. All right, thank you very much. We can now proceed. Please, we'll call Professor Igele to please step forward for his citation to be read to this august body.
Professor Godwin Hojuigile is a distinguished professor of biochemistry in the Department of Biochemistry, Faculty of Basic Medical Sciences, University of Calabar, Nigeria. He obtained his PhD in biochemistry from the University of Ibadan, Nigeria, and has devoted over 3 decades to teaching, research, and academic leadership in the biochemical sciences. Throughout his industrial career, he has played a pivotal role in advancing biochemistry education and research, while mentoring several generations of undergraduates, postgraduates, and doctoral students who continue to make significant contributions in academia, research institute, and industry. Professor Igile has established himself as one of the Nigeria's foremost biochemists through his outstanding scholarly contributions and sustained commitment to scientific excellence. He has authored and co-authored numerous peer-reviewed publications in reputable international journals, with his work attracting more than 1,700 citations and an H index of 19 and high 10 index of 35, reflecting the broad impact of his research within the global scientific community. His publications continue to contribute to the growing body of knowledge in biochemistry and related biomedical sciences. Beyond his research accomplishment, Professor Igile has served the University of Calabar in several academic and administrative capacities, contributing significantly to curriculum development, postgraduate education, and institutional research advancement. He has actively supervised numerous MSc and PhD candidates and remained deeply committed to nurturing young scientists through mentorship, scientific collaboration, and research capacity building. His dedication to academic excellence has earned him the respect of colleagues and students alike. Professor Igile is an active member of the scientific community and has collaborated extensively with researchers across Nigeria's and international institutions. His professional engagement has fostered multidisciplinary collaborations and strengthened research networks aimed at addressing professing biomedical and public health challenges. He continues to contribute to scientific conferences, peer review activities, and professional development initiatives that promote excellence in biochemical research and education, widely recognized for its integrity, scholarship, and unwavering commitment to scientific advancement. Professor Godwin Hojuigile remains an inspiring and academic leader whose contributions continue to shape the development of biochemistry and biomedical research in Nigeria and beyond. Thank you.
Thank you, Prince. A hand of applause. Thank you. Thank you so very much. Professor Igile, right? I hope I'm pronouncing it right. All right, thank you. So you would have 20 minutes that is allotted to this lecture. So ladies and gentlemen, I present to you Professor Igile, that will present the second plenary lecture. Thank you. Please welcome him. Thank you.
Good morning, all. My presentation is environmental based, and it is a patent. It is a patent that was approved by President Olusegun Obasanjo in 2005. the challenges we had in the Niger Delta with so much pollution and environmental degradation was the reason I had to veer from phytochemistry and phytomedicine into environmental remediation, especially when Venunia amygdalina, Venunia colorata, and Venunia calvaona, those three Venunia group plants showed very effective antioxidant activities and were able to promote biological oxidoreduction reaction within double bonds and single bonds of the carbon-carbon skeleton of the hydrocarbon. So that was why then it became part of the formulation that was patented and that has contributed to about 30% of the nutrients being used in the Niger Delta for bioremediation of hydrocarbon polluted sites. The nutrient is balanced with 3 nanoparticle compounds and 4 microorganisms, 3 coming from bacteria, 1 coming from the fungi class. You all know that the Niger Delta is the geographical region of Nigeria where oil exploration and gas extraction take place. As a matter of fact, Ondo State, where we are, is one of the states in the Niger Delta. Since the discovery of this oil, there has been persistent exploration activities in the region without contingency plans for the remediation of potential hydrocarbon pollution or other ameliorative interventions. Remediation protocols started in the past 20 years with doubts of whether Nigerian scientists have the technical and scientific capacity to carry out remediation works. Several site characterizations have been conducted and in the region to determine the extent of pollution with a view for bioremediation interventions, and this has been ongoing. And that yellow, the yellow states you see there, including this Ondo State, Edo, Delta, Bayelsa, Rivers, Akwa Ibom, Abia, Imo, Cross River are the Niger Delta states that are suffering from environmental degradation. Now, but the major pollutants from oil drilling and storage, because we can't be talking about the remediation with nanoparticle formulated product without us talking about the extent of pollution. So the major pollutants from crude oil drilling, storage, and the transportation, refining, sale, and the worst of all, bunkering, is total petroleum hydrocarbon with C23 compound being the most troublesome, but and of course BTEX compounds of benzene, toluene, ethyl benzene, xylene, both auto and the methyl xylenes, and most recently naphthalene as the volatile organic compounds. And then more troubling is our findings of the polyaromatic and polycyclic aromatic hydrocarbons we generally refer to as PAS, being showing high concentrations in subsoil, groundwater, and of course in surface water throughout the region. The next troubling part is heavy metals that accompany oil drilling and other activities within the environment, including, of course, mercury, arsenic, lead, cadmium, and iron, with mercury being a major heavy metal of global concern. So, and of course, At the moment, with C23 compounds, specifically the tricosane type, this is a heavy fraction hydrocarbon, straight chain aliphatic, and it is a hydrocarbon that serves as a key chemical fingerprint to trace pollution origins, assess the extent of environmental weathering, and indicate the persistence of locked chain toxic residuals. Of course, scientists and environmental forensic teams use N-alkanes like C23 to determine the concentration of C22 and C24. Sources of pollution in the soil and groundwater, some of them are petrogenic and some are biogenic and some are anthropogenic. And we all know what all of that means. And then I will like to skip most of this. Note that these pollutants are very highly biopersistent, highly bioaccumulative. They also enter the food chain through plants. Our last research that is ongoing, the present research that is ongoing rather, is also showing very high uptake of hydrocarbons. It both PAS, BTEX, and TPH in ugu leaf, or what we call Teipharia occidentalis, pumpkin leaf, and in water leaf, Talinum triangulare. All of that bioaccumulate a lot, and they are part of the primary food chain. Of course, I would like to show you the pictures of how you can see the pictures of the pollution in the Niger Delta states. I see all of that in Ubeji community in Warri. I have bioremediated that. I was the one given to bioremediate this particular one. That is in Ikara community, south of Edo State. It's not that bioremediated yet. This is Atijagala in the Warri Southwest local government. This is in Efiokoro. Efiokoro is towards the Warri River from Warri Refinery. This is in, it's still Efiokoro, very badly contaminated water body. This is at Koko community, the southern part of Koko. This is at the Warri South local government, close to Focado's communities. And this is at Ahoda, Share Flow Station 9. I have remediated that. I was the one given to remediate. And this is a site I'm remediating now at Kedere in Gokana local government. As soon as we open the soil to start the remediation, look at the pure crude oil that is there. So we have to leave that portion because we discover it's a major oil well. Call in government officials from Federal Ministry of Environment and High Prep to take custody of this portion. This is also at Kedere, but this is lot 26. The other one is lot 27, and it's in the southern part of lot 27. So, well, you have seen all of that pollution. And then, of course, there's a conceptual diagram here showing the pollution and how the pollutant goes down to the groundwater and subsoil. You have to know that once crude oil of any sort drops here, it plumes. It goes through vertical and horizontal plume. The vertical plume goes down to the subsoil, down to groundwater. And the horizontal plume spreads even very far and wide. That's why when an oil pipeline bursts, a lot of contamination takes place both in the farmlands and the groundwater and the subsoil. It kills a lot of plants the crops are stressed and their growth becomes stunted, and the soil is no more viable for agricultural purposes. This is also a flow diagram of source path receptor linkage pathway, showing how any damage from a pipeline resulting in a spill goes through the soil and goes through other matrices. The key matrices are air, soil, and water, and down to the receiving vessels or receptacles in the pathway, resulting to all kinds of toxicities, both mutagenic and carcinogenic toxicities. Now, having gone through all of that, we will then review our journey on the nanoparticles technology we have applied in bioremediation. Nanoparticles are tiny materials that range between 1 and 100 nanometers in size, and they usually present as fine amorphous or crystalline powders with high solubility in water. Examples include iron oxide nanoparticles, nano-zero valent ion, silver nanoparticles, and carbon-based nanomaterials we call the biochar. In our own study and our own design, we have used iron oxide, sodium tripolyphosphate. When we don't have enough supply of sodium tripolyphosphate, we replace it with sodium triphosphate, because both of them have the reaction capacity to carry out degreasing, emulsification, and damage to the carbon bond, freeing the carbon complex compound to allow for microbes that utilize the carbon atom as food to eat it, and that results over time, say 2, 3, 4 months, in complete bioremediation as we have seen it during our journey. Because they are so small, they have a massive surface area relative to their volume, and this gives them unique physical and chemical properties such as enhanced strength and conductivity, which differ significantly from larger bulk materials of the same composition. Their high surface area to volume ratio makes nanoparticles highly reactive and efficient, perfect for speeding up chemical reactions or serving as catalysts during the breakdown or degradation of a complex hydrocarbon compounds, especially the C3 to C30 compounds. And these are the commonly used nanoparticles, the nano-zero valent ion, which I use. Of course, I also have used in another formulation silica nanocomposites, especially sodium silicate. Sodium silicate is produced from soda ash dens and ocean sand at temperatures of about 150 degrees centigrade. It melts it to form the sodium silicate crystals, which we can solubilize for use in detergent, soap, and other products. But in this case, we use it also as a nanoparticle. Titanium dioxide is also a very good nanoparticle, and other biogenic nanoparticles and inorganic phosphates, like I mentioned before, sodium tripolyphosphate and sodium trisodium phosphate. You can see that this particular work is in press, because all this while I have not been publishing from this research work because I was not permitted yet to publish because of my undertaking with the federal government that approved this work, that gave the patent and all of that. But now I am I have been told that I can go ahead to be publishing, so our papers are now going into the press. Now, this is commonly used. I have told you about the trisodium phosphates also, and the sodium silicate, trisilicate, and the biochar and agro waste. We have a lot of water hyacinth in Nigeria. If you harvest water hyacinth and even banana leaves, plantain leaves, we can char them at 300 to 500 degrees centigrade if you have a plant like that to form biochar. The biochar is a good nanoparticle, very good nanoparticle for us to use. Now, but what are the key chemical mechanisms of nanoparticles? They enhance bioavailability via surfactants. And that is the reason why our formulation is some surfactant twin 80 with sodium silicate, with extracts from melina tree, melina bark tree, the bark of melina tree, the extracts from there, from Benunia amygdalina leaves, the extracts. So all of that is balanced so that they do not kill the microbes, carry it. That's why Trichodema viride, which has very good shell cover, is a very good candidate and is a hydrocarbon utilizing organism. And then of course Bacillus subtilis and Pseudomonas species, those are some of what we use in the formulation, and they have been very potent, cleaning oil and degrading oil 93 to 99% in all the sites we have worked and from our laboratory. So we can now look at nano bioremediation integrates nanotechnology and microbiology to clean up hydrocarbon polluted sites. And nanoparticles enhance bioremediation by increasing the bioavailability of toxic compounds, providing localized oxygen immobilizing microbes, and acting as catalysts that break stubborn carbon bonds. You have to also know that once we bio-augment this nutrient carrying nanoparticles in the soil, the bio-augmentation causes biostimulation, and so the microbes in the environment begin to multiply, and they come up to about 5 times 10 to power 7 in population, and that is so much, and begin to utilize and break down the hydrocarbons. Usually 3 to 6 months the site is clean. All the sites we have worked, they have been adjudged clean by UNEP and HIPREP. So you can see me there. You can't miss me from my small stomach there. So in this, the TPA contamination in lot 46 was 12,644 milligrams per kg of soil. Volume of contamination was 19,000 metric tons, and the area to be treated was 9,861 square meters. But after treatment with nanoparticles fortified biosurfactant nutrient, the TPA concentration decreased significantly to So the TPA concentration decreased to 977 milligrams per kg of soil during a period of 96 days. That degradation was more than 90-something%. Now, this picture is showing my staff. My staff are made up of biochemists, chemists, geologists, and the microbiologists. So the four of them on this pink it's not there. Okay, the four of them on the reddish coveralls. One is a geologist, one is a biochemist, one is a microbiologist, and one is a chemist. The person with the white shirt is my PhD student, Dr. Gabe Osogi. What he did, he isolated 3 bacteria, 1 fungus from Kedere community of Gokana. He used 2 key nanoparticles, including sodium tripolyphosphate and ferric oxide, at equal ratio 1:1. He diluted a chlorine nutrient that came out of it and applied 1:4 and applied at 1 liter of diluted chlorine nutrient to 100 kg of soil using a low spray machine. The treated soil using both biostimulation and bioaugmentation was windrowed. It was windrowed and spread alternating every 7 days for a period of 90 days. The degradation of pollutant, TPH, BTEX, and PAS were monitored using GCFID. All contaminants were significantly reduced after 94 days by 94 to 98% for TPH, BTEX, and the PAS. Now, look at the biosurfactant nutrient formulation: Venunia amygdalina leaf extract, aqueous leaf extract, melina tree bark extract, twin 80 surfactant, water, and fermented cassava extract. Now, this was loaded with Bacillus subtilis. These are the microbes: Bacillus subtilis, Aspergillus aeruginosa, Rhizospore species. And then the nanoparticles used were detergent-grade zeolite powder, sodium triphosphate, and iron 3 oxide. That was the formulation, of course, which was approved and patented. Now, that was what was used. This is chlorine. We sell it in drums of 200 liters. These blue drum, plastic drums of 200 liters. That's how we sell it. And it's cheap. 1 drum is 800,000 naira. But we also sell in gallons like this. And that is the one that is from melina. And when it ages, it is this one. When it has aged, see how it looks like. And it's stable, very reactive and good. So I encourage you, if you have any such site to bioremediate from government, federal or state, we are here. You partner with us and we will supply you with the chlorine bionutrient fortified with the right nanoparticles and microbes, and your work will go very smoothly, and bioremediation will be assured. And that is the reason why I look at this kind of sludge and look at the site that has been treated before and after. And this is the breakdown of, these are the results of the breakdown of hydrocarbon, TPH, BTEX, and PAS. This is how they look like in different communities of LMA, Gokana, Kana, and Ahoda. And see how the chart is showing after 90-something days. Look at from here, it has broken down to almost nothing and within regulatory limits. Look at for PAS, no, this is for BTEX, the same profile. Look at for PAS, the same profile after 94 days. This is the results we get. And we also treat the groundwater. We designed this plant. I designed it, and the plant has been used in more than 10 locations in Ogoni and Eleme. and a holder for the treatment of groundwater, and irrespective of the contamination, this plant has cleared and degraded every single PAR compound and BTEX and TPH compounds, and we have been successful. So this design is patented against my name, and when we treat the water, this is hydrocarbon polluted water, but look at when that plant treats it, because we use the pump treat inject method, and at the same time we compress and sparge. Air sparging continues. We set up sparging systems while that is going on, and this is the result we get, and we inject it back, so it dilutes until there is nothing again left. This is how the water contamination groundwater is in LMA, Gokana, Kana, and Ahoda. But look at the treatment now for TPH, and we only did for TPH because it's the same thing that we got for PAS and for BTEX. And I want you to see the general activities outside. This pit contains crude oil recharge, and it bleeds from the bottom. And these pits are all treated. This is well treated. It is commissioned. This area is treated. Look at this. It's also treated. This is undergoing treatment. It has been inoculated with our nutrient, and is undergoing, as I talk, is ongoing. And that drawing of that water treatment plant, this is the water treatment plant, and it's connected throughout the site like this. You see those pipes coming to and pressurized like this to depths of 10 to 18 meters. And see, those are the pipes. These are air sparging pipes with control valves. Those are compressing points, both integrated and whole air sparging systems. And of course, that have resulted to all of this bioremediation. I don't need to bother you further with the bioremediation. Thank you very much. That is our journey, and we are happy with the results we have had for the past couple of years. We are also happy with the laboratory work that has been ongoing, and we are also available for collaboration in terms of because at the moment we are looking at how these compounds or the constituents of our nutrient can be involved in molecular studies against hydrocarbon compounds for spot on remediation.
Right. Thank you so very much, Professor Yele. Please, another round of applause for this erudite lecture he has delivered, and very practical too. These are the kind of works we really do need in this country that impacts directly on your communities. Thank you. Thank you. Please take your seat. So we have had the two plenary lectures. The first one was talking directly to the early career scholars amongst us. And essentially what he has said is that if you want to improve your career, you have to do it through consistency, persistence, foresight, and establishment of appropriate linkages. That's what you need to do. And you have to do it, or rather you have to hit the ground running. Do not wait until you get to your PhD research, and that's when you start thinking seriously about research. He says that you start that from your BSc project research. That's where you start. And then you move along that line persistence, overcoming all obstacles. He also talked about the critical, significant role that AI is now playing in global research. The second speaker, Professor Igele, he discussed the nature, effect, and the devastating human cost of oil pollution in our Niger Delta. If you've been there, you really will see that it is a very serious problem. And he has shown us the practical things that he has done to try and solve that problem. And I hope he is getting the support that he needs from our government. So he shared with us his experience in the attempts to provide solutions by using nanoparticle technology. That's in short what these two very fine gentlemen talked about. Now I said we're going to take a few questions because we're really running behind schedule. Okay. So we're going to take 2 questions for each of the speakers we have listened to. Let's take 2 questions first for the first speaker, Professor Ibrahim. If you have any question or any contribution you want to make, please put up your hand. You'll be identified and then you can speak. Yes, sir. Can somebody take the microphone to me? Microphone. Sorry? There. By me.
Okay. Thank you, Mr. Chairman. Professor Awa Ibrahim, thank you for your very strategic, progressive and innovative research. I was particularly touched by the aspects where you focus on AI-assisted epitope-based vaccine. I'm also impressed with the fact that you identified 300 epitopes, right? And you multi-targeted the 300. I say you identified 300 epitopes, right, in the trypanosome that you used. And I'm also happy that you multi-targeted the 300 epitopes. Okay, so the question is this. Number 1, are we sure that all the epitopes are involved in the pathogenesis of trypanosome? Now, number 2, you know the problem we have with all these infections is antigenic variation. And that's why I'm impressed with that multi-targeting. However, within an epitope, is there a possibility that you could also have antigenic variation? That means the sequence of an epitope could be altered. Now, if that is the case, how did you surmount that problem? Because what you said had to do with the fact that you were able to successfully identify all the possible epitopes, which was a good one. But if we now have a problem wherein we have another serious level of antigenic variation within an epitope, how did you overcome that? Then concerning type 2 diabetes, sorry, Prof, I'm rounding up. Concerning type 2 diabetes, where you interestingly identify sialic acid, okay, being decreased in the pancreas, increase in some tissues that are easily damaged during diabetes, kidney and liver, which means that possibly sialic acid plays a role in the pancreas function. Have you been able, I'm talking fast because of my time, which means that possibly sialic acid plays a role in pancreatic function because it's decreased in the pancreas, increased in the liver and the kidney in diabetes. So have you been able to identify its physiological role? Then number 2, have you been able to investigate the mechanistic activities underlining the decrease of salicylic acid in the pancreas, increase in all those organs that are damaged. Now, this last question is for me to enjoy myself. In case you have not, I'm open for collaboration in that respect. So the first question, I needed to address that. Thank you.
Thank you very much. Any other question, please? Okay. Dr. Tade, please. Somebody. Comment, yes. Comment, yes. Please, we will beg you to make it very...
Yeah, thank you very much, Prof.
We want to go and eat.
Okay, thank you very much, Prof. What I just wanted to say is, Professor Howell, Namu. I said, and also by extension to the second speaker, that please, in all your work, I've been seeing men. Don't be gender biased too. I am standing for my gender here. Collaborate with us and pull us along. Don't leave us on the floor, please. Put women in your team. You need to push us to become part of it, that we're visible in the global world. Thank you very much.
Thank you very much. Thank you. All right, those are the two question and comment we will take for the first speaker, please. So let us give him time to respond, and then we will now take for the second speaker. Thank you.
Thank you so much. Let me start with this one. I want to tell you, I think some 2 weeks ago, a colleague came and told me that, Awal, are you having, your lab is becoming like a nursing home? And because of the number of female, so presently I have more female students, far more than male students. That I assure you. Unfortunately, this is what it is. I think Dr. Salman actually met me last week that there are so many women, and I'm proud to also tell you that I think my first PhD student was actually a female. Yes, both as major was a female, also as minor was a female. So I think I don't have the clear statistics, but roughly I can tell you I operate for now at around 60-40. In fact, the department, they used to say that, Bashir, you once asked me, well, why are they pushing more ladies to you? I think you asked me this question. You understand? In fact, I told him that, I could remember, I told him that you see sometimes ladies are even simpler to handle because they obey instruction. You now, small thing, when you have one girlfriend will just carry you away and things will get scattered. So actually I'm well gender sensitive, and that's how I operate. But of course, despite the fact that we are gender sensitive, we are driven by merit. That merit is the primary criteria, and then we are driven by that. Now to the scientific question. The first one, the issue of using AI, why we have about different candidates, and how do we now make sure that that will eventually work. The whole concept is that eventually among all the fragments we will construct, just from these fragments we have 75, 53 and 83. We have optimized, like I've said, about 400 different combinations within those fragments, so that we want to arrive at one that is potentially viable, that has taken care of most of your concerns. We are subjecting them into other AI pipelines. You understand? So that just what I've showed you has to do with allergenicity, toxicity, and others. So we are eliminating those problems initially. Then subsequently, after the recombination of this, we are having 800. We also further subjected them to further tests to make sure that this thing, what we are having, are actually potentially good and viable vaccine candidates. So essentially, of all these 400 that we have reconstructed, we are hoping to have one that will have all the necessary features that has overcome most of these barriers that you have raised. I hope this clarifies. Yeah, so where we are now is like halfway. Now the other issue is antigenic variation. How do we circumvent antigenic variation? Unfortunately, before I come to that point, Professor Obadoyi has just left. Professor Obadoyi is actually one of the experts, globally non-expert as far as antigenic variation is concerned. In the lab in, I think, UK or Glasgow, in the UK anyway, he worked on some of them. Now, the issue, we have what we call variable surface protein, and then we also have non-variable surface proteins. Before the part of the challenge, people we have been focused, including Professor Obadoyi, I was thinking he would ask me this question. Yeah, he thought about it. Huh? I was hoping he would ask me this question. Before, they were all focused on what we call variable surface glycoproteins, because, and those are the key players, because the thinking then was that those are actually the ultimate blockers. They'll cover everything. Now the thinking has changed now, that we have non-variable surface protein, specifically phospholipase C and acid protease. These are the two candidates. They are non-variable and they are also exposed, and that makes them good targets. Unlike people following variable, we are now following non-variable, and we now know they are also exposed, so they are also subject to attack by the immune system, and they could be good vaccine candidates. The last one is the issue of sialic acid, the role of sialic acid. Yes, like I've told you, actually we have gone far now. I have not shown you. I have a PhD student actually hoping to completely elucidate everything that happens in every tissue, from both the de novo system and also from the salvage system. Actually, he's busy working on that. Yesterday, I was talking with his HOD, so he's actually working to solve that. Perhaps we can discuss about the issue of beta cells so that we see how we can collaborate. Thank you.
Thank you very much. The discussion can continue after this. So if you have any further question or comments regarding the first lecture, please, you can meet him outside during the tea break. You interact and ask your questions or make your comments. We will now entertain two for the second plenary speaker. Do we have any? Okay, you. Here, please. If we can help. But please try and make it short this time around.
Professor Tadi, women are not asking. Professor Gile, thank you so much for your environment impactful research. However, I want to ask, I know that the use of microbes is part of green bioremediation. However, with what happened with COVID-19, you know, I'm getting scared of with the use of microbes in anything. So on that ground, I want to ask, are there now technologies in place that will help us to exclusively improve on the single use of plants without needing to add microbes? You know, we have phytoremediation, okay? Phytoremediation. Can we make it exclusively phytoremediation and get the same results that you have shown us without necessarily including microbes like bacteria or fungi? Thank you.
Any other? Okay. I'm looking for a lady, if there is a lady. No? All right. Where? Oh, okay. Thank you.
Thank you very, very much, Prof. Sigile. Your lecture brings many perspectives to us. They need to stop speaking grammar and start making money alongside what we're doing. So thank you for that. The question I have is, this bioremediation you are doing to this soil, are you also looking at soil fertility, achieving soil fertility? Because that's the real problem of the Niger Delta, that once these pollutions occur, it's not just removing the oil, but restoring the soil for agricultural productivity, because we're also, as biochemists, thinking about food security. Thank you.
Thank you. Can somebody please help? Thank you very much, Professor EJ. No, that's all. He's to answer now. Let me have it. Thank you very much, my dear friend, Prof. McDonald. Your question on phytoremediation is one of the options that we have and we are already applying. I have told you about these monocot plants, Teipharia occidentalis and Talinum triangulare. We are all biochemists here, so we know those botanical names. I say they absorb a lot of these. So it means that that is a marker, is a complete marker now that if we plant it, it will bioremediate, but how deep? It will only, the uptake will not be more than 1 meter. Now our own bioremediation work, we see the structure of the soil geologically going through a very large lithostratigraphy to the aquifer, and usually going so many over 100 meters down, and all of that polluted. So we can use some plants like Melina teak and these other ones we have mentioned for remediation, but to some extent of the soil. Otherwise, going deep to groundwater and the subsoil, we need, of course, some of these plants cannot grow through the clay plate that covers from the old Bini geological plate extends to River State. It also has an underlay of what we call geologically the Akata Formation and the Agada Formations. And all these formations are several meters deep if you look at the geological aspects of that. So that's why we will have to employ technologies involving nanoparticle, and probably as we are exploring in silico options, and then go more into more about molecular biology. So I hope I've answered your question. With respect to Professor EJ, yes, this research is translational research. The translational research gives you a product which is in the market and can be used in technology. But when you are asking achieving soil fertility after bioremediation, first of all, when there is oil spill, the soil fertility metals of magnesium, calcium, potassium, sodium, and aluminium are masked. They are masked to a large extent, and they no more express themselves in fertility terms in the soil. So because hydrocarbon pollution masks them very significantly. After bioremediation, they are unmasked, and you see the concentration become high. I didn't present that. I concentrated and focused on only the nanoparticle technology. That's why. So you see then that these fertility metals are now unmasked. Their ratio sodium to potassium, calcium to magnesium become very, very good, and the soil becomes very, very fertile. So we have observed that, and we have seen that. What danger we must not allow in Nigeria, the formulation I showed you and most of what I have talked about are indigenous. The only thing is twin 80, we have to import twin 80, and a few other materials are imported. Otherwise, Venulia amygdalina extract, what do you call, Melina tree bark extract, water,
even we produce our own sodium silicate so as to generate the silicon dioxide we need, and then of course other micro nanoparticles, we import them like iron oxide, but we are exploring to look for alternative locally available nanoparticles so that the product is cheaper, and we will have everything locally sourced for us, so as not to introduce raw materials into our soil. Because of course, once these microbes we are using complete their work, they undergo cell apoptosis and they die off naturally, and they are no more there. Whatever is left of the oil undergoes remediation by enhanced natural attenuation, which is described as RENA in environmental terms. So we don't have any problem. The problem we have is those who are importing some bioremediating agents, and they come to tell us a lot of lies, whereas we Nigerian scientists, we are as good as they are to be able to formulate and do the right thing as we have seen. Thank you very much.
Thank you very much. Thanks. All right. Yes, that's a very high note at which to end this program, but I crave your indulgence, please, to give us some few more minutes, because the society must say thank you to these fine gentlemen that have imparted some knowledge on us. So the society is presenting them with plaques of appreciation, and to help me do that, I'll first call upon Professor EJ to please come and help us present the plaque to the first speaker, who is Professor Ibrahim. Please come forward for presentation.
Sir, you may sit down. Thank you.
Professor Mohammed Awal Ibrahim. We want to say a very, very big thank you for doing science correctly, for motivating early career, mid-career, and even all of us. Your lecture was brilliant, and we want you to keep it up. This award is presented to you today in appreciation of your outstanding scholarly contribution as a plenary speaker at the 42nd Scientific Conference and Annual General Meeting of the Society, holding here at AKURE 2026. Thank you very much.
Thank you very much. A hand of applause for her, please. Thank you. Then we'll now call on Dr. Tade to come forward, please, to present the second plaque to our second speaker. So, please, can you come on? Yes.
Thank you very much. I mean, the shoe is wearing actually bigger than my shoe, but maybe representing the women fold, on behalf of Nigerian Society of Biochemistry and Molecular Biology, it's a great honor to present this to you for your contribution to this 42nd conference holding here in Abuja. Oh, I love Abuja. Holding here in AKURE. I want to say to you that you're doing something good because science should find solution, and you're finding solution to the problems of the Niger Delta. I wish you a sustained research, and I wish you greater output. Congratulations, sir. Thank you, sir.
All right, thank you very much. A hand of applause for Dr. Tade. All right, so we're well behind schedule. So I'm going to simply say this brings us to the end of this session. So I formally declare this session closed. However, the tea break is ready, and we should all go to the foyer there and take our tea break. Thank you very much for being with us, and we hope to see you back after the tea break. God bless you all.